So on a control system, you obviously have PID controllers that are running most of the furnaces that are out there, whether that's in a discrete format or in a PLC. But there's quite a large variety of tuning and the ability to tune and the accuracy of tuning. So actually having sort of advanced PID control along with auto-tune can get you some really good results. Now I just wanted to show sort of, this is an example of an oven that was running with a PLC and a mechanical contactor, and then sort of changing that out for an advanced PID controller and then an SCR device. And you can see the difference as far as the sawtooth trend that we got with the on-off controller with a mechanical contactor. And now we've got a nice smooth trend, and we've really sort of reduced the temperature variation. So then we move on to sort of the heater side of things. And if we're talking about electric heaters, then the biggest part of an electrical heater is to make sure that it's reliable. And one of the downfalls of an electric heater is actually how it's actuated. So if you have a slow actuating device like a mechanical contactor, then it takes time to switch on and switch off. And that time actually then sort of changes the temperature on that heater. And so you get these sort of dips. And because you're getting this constant sort of change in temperature on a heater, you're stressing the oxide layer on that heater. That eventually will crack and spool off, and then you'll sort of just go through that heater, and eventually that heater will fail. So actually, again, having sort of fast-acting solutions like SCRs to trigger sort of electrical heaters really helps in sort of minimizing that temperature deviation. The next one down here is sort of on the sensor side and having accurate sensors. Here we've got just a little bit of a chart. You can just about see it. Sort of there's a kind of a lighter blue line sort of behind the squiggly sort of purple line at the front. And that squiggly line at the top is actually the control thermocouple, and it's the high limit that's sort of hidden. And that control thermocouple has had electrical noise sort of affecting that signal, so you can imagine how mad that control is sort of working. So actually making sure that you've got accurate sensors is really important sort of within the thermal loop. And the final one here is having trustable data. So you can go through all of this and say, you sort of check the parts go out to the field, the cycle look fine, then you get a failure. And then you go back to the records and you look at the records. But something has happened, either the data's not there or the data's been manipulated. And so you go back to that data and you really have no clue because you can't trust that data. So a lot of the standards have been developed. So one, we've now got digital data, so you don't have that issue with paper charts either running out or getting spoiled. But also, most of the regulations require that you to have some security over that data. That way you can start to trust that data.